Hi, I'm Greg. I'm one of the authors of ScalarLM, which is an open source project that allows you to train LLMs and run inference on them immediately. It allows you to put these pieces together to build combined training and inference loops like those that are used in reinforcement learning on reasoning trajectories. Most frameworks that you see out there, like VLLM, SGLang, or Megatron, or Hugging Face, or Unsloth, there's a lot of them. They allow you to train LLMs, and some of them allow you to run inference on LLMs, but typically they're not put together. What we found over 7 generations of building frameworks at Baidu, at various AI startups, with partners that are large scale enterprises, that they always need these two different pieces. But these two different pieces are typically developed by separate teams. And because they're developed by separate teams, you need to install two different pieces of software in order to train LLMs and in order to deploy LLMs. Now, both are pretty important. You need to, of course, have an inference framework because you need to be able to run the LLM. But LLMs are machine learning models. They're deep learning models. A key aspect of them is that they can learn. They can learn new information. And in order to learn them, we train them with backpropagation. So we need a training framework, otherwise the model can never learn anything new. And we need an inference framework, otherwise we can never use the model. So we found that when we're deploying software like this and building models and building machine learning teams in different organizations, that you always end up needing both training and inference. But because these frameworks are typically historically developed by separate teams, there aren't unified frameworks that allow you to do training and inference. So you either have to go through this um, long and complicated process of exporting models, converting models, manually deploying models, going through your operations team to deploy train models, um, which is just complicated and um, slow. And it prevents you from building applications that actually use both training and inference. So it's pretty complicated to write a loop, especially that scales out to a large scale system that doesn't just run on a laptop or doesn't just run on a single GPU, but runs on an entire rack or a large part of your data center. It's hard to build applications that are going to do both training and inference. We think now is actually the perfect moment for there to be a much better implementation and an open source framework for both training and inference because of reasoning, because models um, when they're thinking step by step to try and generate an answer, that's inference. And the way that they think actually can be changed by the training process. So models can explore different ways of reasoning to solve problems, and the ones that are effective can be selected, and we can use reward models um, to update those trajectories that are doing well, those reasoning strategies that are effectively solving the problem. So we think now is a great time for there to be development on a high performance and open source unified training and inference framework. And that's why we built ScalarLM. So I'm going to start out with a series of videos where I walk through the design of ScalarLM, using ScalarLM, deploying it, building simple applications on ScalarLM. And I'm also going to, because performance is so important when we're training deep neural networks, training generative models like language models, I'm also going to look into and include in these videos some aspects of benchmarking. Now, we already have great benchmarks like MLPerf that are very large scale and at the whole application level. But in order to really understand and debug performance, we often have to break it down and go, a little bit lower level than that. So I'm going to start out by introducing a few quick videos where we, look at various aspects of performance that we put together in order to get good performance at the full application level. And if there's interest in this, I'm happy to, um, you know, add additional videos and kind of take it all the way up to the full application level. So yeah, I think both if you're interested in training reasoning models and you're interested in performance, um, please take a look at these videos and let us know what additional information you'd like to see.